Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell. In this video, I'm going to go over the real-time clock on the Nextion display. For this project, I have 6 text boxes and a button. And these 3 over here are just going to be showing text only. I have the Nextion, the Arduino, and then a real-time clock chip. And then I'm going to show the current settings of the real-time clock. It's a pretty basic setup. In this video, I'm just going to go over the Nextion portion of it. The real-time clock on the Nextion runs in the background, but in order to pull the values, you have to trigger it on something. So I'm going to use a timer, and I'm going to have that timer trigger every 500 milliseconds. So every half second, we're going to update the display. The variables, I've got the conversion variable, which will hold the values. Because the real-time clock is an integer, I'm going to have to convert it to a string before I can show it, and I'll convert it temporarily into the conversion variable, and then I'll store the longer in this time. I'm going to call it the time string. So we'll convert it in the conversion video or cove variable, and then we'll store it over in the time string. Real-time clock values in the Nextion display are stored as integers, and so they'll be vals. So if you were to take one and populate a number field, you could just do it directly. Rtc1 or Rtc2 is equal to num0 or n0.val. We're going to store it in a text field, so we're going to use the cove command to transform the value from an integer to a text. When you call the RTC on the Nextion, you don't call RTC, you call RTC 0, 1, 2 through 6. RTC 0 is a year, RTC 1 is the month, and so on down the line. The year is only 2000 to 2099, so if you wanted to display 1999 or set your value to be in the 19s, you wouldn't be able to do that. You can only set the value between 2000 and 2099. The month is similar. You can only use values 1 through 12. So when you go to set it, which you would say RTC equals 3, let's say, it would set it to the 3rd month. The day is 1 through 31. The hours are 0 to 23. It's a 23-hour or 24-hour clock. It isn't a 12-hour clock. If you want to show it in a 12-hour format, you'll have to do some manipulation on it, like if greater than, subtract 12, something like that. Then the minutes and seconds, that should make sense. Now the day of the week is 0 to 6, and 0 is Sunday, so it starts on Sunday and it goes through Saturday. You cannot set this. It calculates it on its own based upon the year, month, and day. What we're going to want to display on our display will be month /day /year, and then a dash with some spaces around it, then the hour, minute, second, . Now I have the seconds and minutes as if there's 2 digits. We're not going to worry about that right now. 1 through 9 will show up as 1 through 9. It won't be 0, 1. We're not going to do manipulation on that at this point. Now based upon the values RTC1 through RTC6, we'll do 1, which will be the month, and 2, which will be the day, and then RTC0 is the year. So it'll be a little out of order, but then the clock is hour, minutes, and seconds. Now the code for this, we're going to use the conversion function, the COV. There is a new one out, COVX. The COVX has actually been removed from the library, but it still functions. So we're just going to use it right now since this is a simple example. And then you use the runtime clock 1, which is the month, not the year, because remember we want month, day, and then year. And we're going to convert the RTC1 into the string timestring.txt. The time string is the final one we're going to want, but since it's empty right now, we can put it in there. And then 0 is just default. But if you notice on the RTC, you don't have to put .val like you would if it was a number field. You just put RTC1 and it converts it. Then we're going to concatenate with the plus equals sign onto the end of time string a /. And then we need to go ahead and put the day on it. In order to get the day though, if we were to use the cov function again and put time string down here, it would overwrite it. So instead we're going to use the conversion variable, COV variable. I probably should have named it something different because it can be a little confusing. I'll show it to you in the IDE and it'll make more sense. So we're going to convert it into the conversion variable. Then we're going to take the time string and we're going to concatenate on that cov.text, that other variable. And then we're going to put another / on it. I'm going to copy it over to the IDE now. And we want it in the timer. So we want this to execute every 500 milliseconds. So we have our cov variable that we're going to use temporarily, and then we're going to take our time string variable and we're going to concatenate the cov variable onto it as we walk through each one of the real-time clock variables. And you can see that we have the day or the month, the day, the year, and we're adding a / on each one of those. And then we put our space / or our space dash space in between our date and our time. And then we're going to use our hour, minutes, and seconds, which is Rtc 3, 4, and 5. And we're just going to do the same thing. And then on each one of these, though, we're gonna put a colon in between each one. I'm gonna go ahead and run compile on it just to make sure that I have it correct. There, and it was successful. So we're gonna run this in debug now, and I'll show you how it all comes together. And you can see we have the month, the day, and the year, and then the time. And we'll concentrate on these next two in the next two videos. But I'm going to show you that you can write to these values also. So when we hit the reset button, we'll use that just for a test. Eventually I want the reset button to go through and set all of the different devices that have real-time clocks to the same time. So then we can see error over time. But for right now, we're just going to set the real-time clock. And if you look, it's kind of nice in the IDE because it does have a helper, and as you can see, I capitalized it. It needs to be lowercase. And as we select each one, so this one is the year, but I don't want to change the year. Let's change the day. And we're going to set it equal to 5 when we hit the button. So now let's run debug again. Oh, and I got an error. You can't have spaces in your code in this. And you can see it's 8:19 and we're changing the day to 5. So when I hit this button, that should go to 5. Oh, wrong one. The month we have set to go to 5, and you can see that it changed. But what happens if we try and set the year to like 1999 or 5? So let's try and set that to 5 and see what happens. Well, instead of 5, let's make it 6. That way there isn't a question if something strange happens, we know that we have a different number. Now, when I go to run debug again, the other question I would have is, do you think it'll go back to the current month of 8, or do you think the real-time clock will hold the value of 5? And remember, this is running in debug, it's not the actual display. What I've always found interesting is the simulator itself keeps track of whatever time that you set it to. I'm not sure what would happen if I rebooted the simulator, but I have noticed in playing with this that it held the 5. If you go up to this operation and reset the simulator, this will set it to the time of the clock in your computer. And you can see that it went back to 8 now. Now if I hit reset, this should go to 5, and will this go to 6? I seriously doubt it, because the number is supposed to be 2000 to 2099. And I went to 2019. So that's kind of strange that it went to 2019. I'm not sure why it did that. We're going to go ahead and reset it again. And hit reset all. And it went back to 2019. I haven't used these exact numbers in the setting. I did get an error once when I had tried to set it to 0, but this is kind of interesting. I'm going to change it to 7 and see if we get 2020. Like, does 6 equate to something strange. What's interesting is this became 6 and this became 5. Did I make a mistake in what that I did there? So let's go back and look at the code again. Nope, that is the year. So let's go ahead and change the order. Let's go ahead and set the day to 4. And now we'll run it again. But this is messed up, so let's go back here and reset it. And then let's hit the button. 5/4/2019. That's interesting how that came out, but you can see you get strange results. Since I set these last, I guess that it tried to do something with that, and then it came through correctly. If we go back to here, it was 5 and 4, which is correct, but that 6 is wrong. But let's set it to 2054 just to see that, make sure that it does work. So we're going to set our year to 2054, and now let's run debug one more time. Let's set it back, and now let's hit the button. And we get 5/4/2054. So really what you want to do is you want to stick to the values that the Nextion understands, otherwise you'll get crazy results. So you can go through and use the same logic on all of the options for setting things. But for now, let's just set it back to the time that the computer has. And now I do have a display attached. I'm going to upload the code to it and then switch over and show you a video of it. Now you can see that this is the way that it came. So it sets it at 4/13/2005 and the time is 5 a.m. 2 minutes and 25 seconds. Like I said, I don't have the zeros set on it, but it starts to count up. What's kind of interesting is in the simulator, you can set the time on this equal to your computer time. And I'll show you that now. If I go up here and I run debug, oh, I must already be in debug. Oh, no, I gotta close this first. If you want to change the time on the display, you can go over to the debug and you can connect it by connecting down here. I only have one COM port, so I know that it's connected to the display, and you just hit start. Now I'm going to pull this over so you can see the change happen. And when I do the device RTC calibration, it will set it to the time of my computer. And you can see, so now we're set to the regular time. And if I hit the button, then it screws it up just like it did when we did the display, because I went ahead and uploaded the button code to it. But if you unplug the display, and you plug it back in quickly, it'll hold the time. But if I unplug the display and let it sit for a few seconds, I'll time lapse this, but I'll put on the display how long I let it sit. I'm gonna go about 30 seconds. Then you can see that it goes back to that initial setting. In other words, it didn't work. It got it doesn't hold the values, and that's because on these enhanced displays, there's a little spot for a battery right there, and you need a 1220. I buy the lithium ones because I believe you need a lithium battery so that it can recharge when it's plugged in. And you just pop it in there. And now when I go up and I set the time, actually I'm just going to close this all together and we'll start debug again. And then we'll go back here and we'll start it again. Move this back over. And now we're all set again. But now if you were to unplug this, you could leave it set for forever, or for as long as the battery lasts anyway, and the time would hold. So that's about it for the real-time clock. The big thing is that you don't have to put the .val, and you can set it, so you just say RTC equal to that, or you can read from it like I did over here using the cove. But you could also say, like if you had a number field up here, you could say n0.value equal RTC1 or something like that, and that would work just fine also. Now in my next video I'm going to add on to this. So I'm going to go over using the Arduino and a real-time clock, and then after that video I'm going to have a third one using the chip, a real-time clock chip, like a purchased one. Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.